Before discussing front-end technology, let's have a little reminder about what front-end is. So front-end is a part of the software that is viewed by an actual user with his own eyes. This is where we will display buttons, text, drop-down list, colors, messages, and more. So naturally, when selecting a front-end technology, we would like to select something with robust visual capabilities, but something that will not make us work too hard. But first, let's look back at the application types we discussed and see which one of them actually has a front-end. So, web apps? Definitely. We defined web apps as applications that run in the browser and display HTML to the user. We definitely have a front-end here. Web API? Not so much. Clients of Web API are other applications, such as mobile apps, which by themselves might have front-end, but the Web API application itself does not. Mobile apps? Yep, that's the whole point, isn't it? Console? Well, that's complicated. Technically, there is a user interface to a console application, but it's not built separately from the console app itself. And let's face it, there isn't going to be heavy investment in any console application user interface. So for the sake of our discussion, there is no front-end to console. Service? Nope. The whole point of service is that it does not have user interface, so no front-end for you, buddy. Desktop? Of course there is. Although desktop apps varies greatly, the common denominator of all of them is that the user can see them and interact with them. So there is a front-end to the desktop app. Okay, so let's go over the various front-end types and see how to select their technology. First, web apps. Web apps, by definition, have a web-based front-end, which means we are going to use a combination of HTML, JavaScript, and CSS. The real question here is, which JavaScript framework are we going to use? The most popular frameworks at the time of this recording are Angular and React. There are other great candidates, such as Vue.js, but I really want to focus on the most popular ones with the largest communities. So first, let's compare Angular and React popularity. As you can see in Google Trends, they are quite similar in popularity. Looking at StackOverflow.com, we can see there are more questions regarding Angular than those regarding React. But since Angular is older, it was founded on 2010 as opposed to React 2013, the numbers are actually quite close. Let's compare the capabilities. Angular is a full-blown framework with a full set of capabilities a front-end framework will need, such as data binding, state management, routing, services, and lots more. Learning Angular can take time, and it won't come easy even to developers with a lot of experience in web development. React, on the other hand, is more libraries than a full-featured framework. It focuses on the user interface side and is great at it. If other capabilities are needed, then separate libraries should be used. On the other side, React's learning curve is much shorter, and web developers can get up to speed with it in a matter of days, while Angular training can take a few weeks, if not more. So if you are looking for a one-stop solution for all your web front-end needs, and you have the time for training, opt for Angular. Otherwise, go for React. Okay, let's talk about mobile apps. When designing mobile app, the first thing we need to do is to decide the development approach we are going to use. There are three main approaches for mobile app development: native, hybrid, and cross-platform. Basically, those approaches represent the trade-off between development time versus capabilities, and your selection should be based on these factors. Let's discuss these approaches. Native apps, as the name suggests, use the native development platform for each mobile platform. For example, native iPhone development can be done using Objective-C or the Swift language with the Xcode development tool and using the iOS SDK. Android apps, on the other hand, are developed mainly with Java using Android Studio and the Android SDK. As you can see, iOS's native apps environment is completely different from the Android one, and you will have to have developers that expertise in each one of those environments. On the other hand, native apps offer full access to all the phone's capabilities, including camera, accelerometer, Bluetooth, file system, text, and more. You are not limited in any aspect, and you can take advantage of any feature you would like. In addition, native apps are very responsive and will offer the best user experience. Hybrid apps are the complete opposite of native apps. Hybrid apps provide thin native wrapper, usually with tools such as PhoneGap, and in it you will find a regular web page complete with HTML, JavaScript, and CSS. You can think of hybrid apps as a glorified browser with limited phone capabilities, but it's still a web page and requires internet connectivity. Accessing phone capabilities such as accelerometer or camera can be a challenge with hybrid apps, and there are a lot of limitations. In addition, hybrid apps provide inferior user experience compared to native apps, and their graphics performance is limited. In recent years, a new standard emerged called Progressive Web Apps, or PWA. This standard allows hybrid apps to behave much more like native apps, with offline capabilities, improved hardware access, and more. The PWA standard looks quite promising, and you should definitely keep an eye on it, but it's still not mature enough. Apple added support for PWA in iPhone only in iOS version 11.3, and even in this version it's still limited and not on par with Android support. So it's definitely worth looking into, but perhaps too early to actually use it. The biggest advantage of hybrid apps lies in the development time. Aside from the native wrapper, which do require a bit of learning, everything else is a regular web development. If your team knows how to develop web apps, they will know how to develop hybrid apps. It's that easy. In the middle, between the native and hybrid apps, we find the cross-platform apps. The cross-platform approach works like this. The development is done in a specialized environment, not linked directly to any of the mobile platforms. The leading cross-platform environments today are Xamarin and React Native. In Xamarin, you will develop in C# using Visual Studio, while in React Native the development is done with JavaScript, using one of the many IDEs supporting React Native. After the development is done, you compile the application, and the result is the native app for the selected platform. You will be able to compile the app for iOS and for Android and get native apps for both of them without writing a single line of Java or Objective-C. So pros of using this approach are clear. We write the code once and it runs on both platforms as native apps. What are the cons? There are a few. First, there is usually a gap in supporting latest capabilities of the native operating system, and the cross-platform tools always play catch-up with the various mobile platforms. In addition, cross-platform apps do not work well with heavy graphics, so if that is your plan, you will have to go to native apps. Last but not least, for some scenarios, you will still have to resort to native programming, especially when accessing specific sensors. So in this case, this is not pure cross-platform. So let's summarize. In this table, you can see the differences between the three approaches. Use this table as a reference when selecting technology stack for mobile apps. I hope it will help you the way it helped me. And now, for the third and last front-end app, which is a desktop. Now, let's face it. If you are developing a desktop application which will run on a PC, most chances are you are targeting Windows. So I limit the discussion to Windows-based desktop apps. On Windows, we have three options for desktop development: WinForms, WPF, and UWP. WinForms is the oldest technology, introduced in 2001 together with the .NET introduction. It's similar in concept to older platforms, such as VB6, and is quite limited in its graphic capabilities. For example, try to implement rounded corners to a button. It's possible, but oh boy, it's so hard. On the other hand, developing in WinForms is quite easy, and the learning curve is short. WPF, introduced in 2006, improves the situation dramatically. It offers full control on the visuals and gives complete freedom to visual designers. You literally can do whatever you want. But, and there is always a but, it's much more complicated than WinForms. In order to use WPF, you will have to learn a new language, XAML, which, similar to HTML, functions as a markup language to the user interface. XAML is a very rich markup language, and it's very easy to get lost in it. It's even safe to say that an inexperienced WPF developer can cause more harm than inexperienced WinForms developer. Our last contender is UWP, or Universal Windows Platform. UWP is the effort done by Microsoft to unify all its screens, like PC, Xbox, Windows Phone, Surface, and more, to support a single UI platform. The result of this effort is UWP, which is quite similar to WPF, but with important differences. First, it runs in a sandbox, meaning it does not have full access to all the operating system capabilities, similar to hybrid apps in mobile. Second, as mentioned above, it runs on all Windows-based screens. So if you want to develop an app for Windows and Xbox, that's the way to go. Third, it's much less mature than WPF. So that summarizes the desktop alternatives. In this table, you can see the summary of the 3 alternatives we talked about with the main differences between them. As usual, you are invited to use this table as a reference for your future systems you will work on. And now let's select the data store technology.